In this video, we are going to look at part 2 of this topic, valency, formation of compounds and chemical formulae. In our previous class, you would recall that we treated how we can write the correct chemical formulae for binary compounds using the knowledge of valency. Now, in part 2 of this topic, we are going to see how to write the correct chemical formulae of a compound. Our focus now will be trinary compounds. What are trinary compounds? Like the name goes, tri, a compound that contains 3 elements. So, how can a student be able to write the correct formulae of a compound that is made up of 3 elements? Very important. Usually, every trinary compound is made up of what we call a radical and then a particular ion. Alright? Could be a cation or an anion. Remember what I said? Every trinary compound is made up of what? A radical. Look at it. So I'll say that in the formation of trinary compounds, radicals usually combine with other ion. So this should be usually combined, not combines. English. Alright, so radicals usually combine with other ions so that this trinary compound will be formed. Now, you know from our previous class, we explained that radicals is simply a group of atoms that forms what? A single unit. Usually you have 2 atoms of different elements, they come together, form a group. And then that group would give you just a single unit. That single unit usually contains 2 atoms. So that 2 atoms now, which is inside a radical, or which makes up radical, will now react, alright, with another ion to make it 3 elements in one compound. So it's very important for us to know the valencies of radicals. Once we are able to understand that concept, then it will become quite easier for us to see how trinary compounds are formed. So that next time, if you want to write tetraoxosulfate 6, you'll remember that it is H2SO4, that it is not HSO4. If you want to write lead 2 trioxonitrate 5, you would know that it is Pb open bracket NO3 close bracket 2. That it is not Pb NO3. Are you ready? So please come along with me. We have on the board here common radicals, their names, and of course their valency. One of them we have here is NH4+. The name of this NH4+, that radical, is called ammonium ion. Ammonium ion. So don't forget that. And the valency, just like you can see there on the board, is +1. You can say that here. Okay? Another one is CO32-. CO32-, the name is trioxocarbonate 4 ion. And what is the valency? Of course, you can see that. -2. Taken from here. Then we have SO3 2-, trioxosulfate 4 ion. The valency is -2. What about SO4 2-, tetraoxosulfate 6 ion? The valency again is -2. Then we have NO3-, the trioxonitrate 5 ion. The valency, as you can see here, is negative, so it's -1. We have the hydroxyl ion, OH negative. Sometimes you can call it hydroxide ion. Is that okay? -1 is the valency. So it's very important as a chemistry student to be able to remember the valency of these radicals so that you can be able to write the correct chemical formulae of a compound that is made up of these radicals. Let us quickly look at an example here, okay? Let me put something downward here. Just imagine if you hear calcium trioxocarbonate 4, it's written as CaCO3. Why is that compound written like this? But if you hear sodium trioxocarbonate 4, it's written as Na2CO3. So why is it that in the case of sodium we have 2, atomicity of 2 here, but in the case of calcium, we don't have that atomicity of 2. The atomicity here is 1. What's the reason? So we're going to use our previous knowledge for binary compounds and see how this trinary compound is obtained.